Good evening, children. Welcome to my class. In this session, we are going to verify Ohm's law using Ohm's law apparatus. See, Ohm's law states that electric current through a conductor is directly proportional to the voltage across it. Means, if you increase the voltage, the current also increases. If you decrease the voltage, the current also decreases across the conductor. So now I will show a special apparatus known as Ohm's law apparatus to verify Ohm's law. See this is Ohm's law apparatus. See, this Ohm's law apparatus is provided with ammeter, rheostat and voltmeter and a resistor whose resistance you are going to calculate, and a circuit. Ohm's law circuit is also given, a drawing is also given. Observe this one. Observe the readings of the milliammeter. The range of the milliammeter is 0.5 milliamps. So 0.5 milliamps is divided into 10 smaller units. Observe this carefully. So let us calculate the least count of the milliammeter given in the apparatus, Ohm's apparatus. See this one. Observe this. The range of the milliammeter is 0 to 0.5. So 0 to 0.5 is divided into 10 smaller units. So its least count is equal to total range is 0.5 milliamps divided by 10, which is nothing but 0.05 milliamps. Next, see this one. Observe the 10 units, smaller units. So its least count is equal to 0.05 milliamps. Okay, first of all, you have to calculate the least count. In the same manner, let us calculate the least count of the voltmeter provided in the apparatus. Okay, see the voltmeter given in the apparatus. Observe that carefully. Observe that carefully. See that apparatus. See, a voltmeter is provided and a milliammeter is provided. Rheostat is provided. Now see that one. See that milliammeter. Okay, the readings are given in milliamps. Milliamps 0, 0.5, 0.5, 1, 1.5 milliamps, 2 milliamps. So the voltmeter reading is, what is the voltmeter reading? Voltmeter reading also given in 0.5 volts, 0.0, 0.0 volts, 1 volt, 1.5. So the least count is also 0.05 volts. 0.05 volts. Are you clear about that one? Now see this one. Switch on the circuit. Switch on the circuit. Observe this. You can change the amount of current flowing in the circuit with the variable resistance known as the rheostat. Note down the readings of the voltmeter and milliammeter. When the potential difference is 0, the milliammeter also shows 0 amperes, milliamperes current is flowing in the circuit. Now I am changing the current flowing in the circuit with the help of the rheostat. Now observe this one. The current flowing in the circuit is 0.2 milliamps. So the voltage is 0.2 volts. 0.2 volts. For 0.2 milliamps, the voltage is 0.2. Okay. Once again, what I am doing, I am changing the current flowing in the circuit. Observe this one by adjusting the rheostat. Okay, rheostat is nothing but, you have to remember, rheostat is nothing but variable resistance. Now the milliammeter shows 0.5 milliamps current is flowing in the circuit. Now see that 0.5 milliamps current reading. See that 0.5 milliamps current. Now the potential difference is also 0.5 volts. 0.5 volts. See that? See the milliammeter reading, it is 0.5 milliamps. Okay, for a potential difference of 0.5 volts. Now I am allowing 0.8 milliamps current by adjusting the position of the rheostat. Okay, see this, I adjusted the position of the rheostat so that 0.8 milliamps current is flowing in the circuit. 0.8 milliamps current is flowing in the circuit. See that I am adjusting the position of the rheostat. I am allowing, we can allow the required amount of current in the circuit by adjusting the variable resistance. Okay, so 0.8 milliamps current is flowing. Now the potential difference is also 0.8 volts. 0.8 volts, see that one. 0.80, okay, 0.5, 0.5, see that 0.6, 0.7, 0.8 volts. 0.8 volts. Okay, for a potential difference of 0.8 volts, the current flowing in the circuit is 0.8 milliamps. Okay, 0.8 volts. Observe the reading carefully. Note down the values in your textbook. You have to plot the graph for that one. Okay, see the reading of the milliammeter. It is 0.8 milliamps. 0.8 milliamps. Okay, once again, I am allowing a current of 0.0. See this 0.8 completed. Now I am allowing 1 milliamps current. 1 milliamps current. Okay, for 1 milliamps current, the potential difference is 1 volt. See this milliamps current. Okay, the potential difference is 1 volt. In the same manner, 1.5 I am allowing current of 1.5 milliamps. The potential difference is also observed that milliamps, 1.5 milliamps current is flowing in the circuit. Now the potential difference is 1.5. For a current of 2.0, that is 2 milliamps, the voltage is 2 volts. Okay, so with this we proved that the current flowing in a circuit, electric current through a conductor, is directly proportional to the voltage across it. So this is the verification of Ohm's law. So with this we can calculate the resistance. The resistance of the resistor in this circuit is nothing but R is equal to V by I, which is equal to 0.5 divided by 0.5 or 0.8 divided by 0.8, which is nothing